Hi everyone, today we'll be reviewing atoms in their neutral form, finding the number of protons, electrons, and neutrons in each, and also taking a look at ions. Let's go ahead and get started. First off, when looking at the periodic table, make note that these are all elements in their neutral form, meaning they have no charge. If we take a close look at one of these elements, let's just say carbon for example, in the center is the element symbol. In this case, it's C for carbon. On the top, you'll find the atomic number. This number represents the number of protons in the atom. The atomic number is also the identification, if you will, for an atom. Each element has a different atomic number, and this number does not change. Next on the bottom, we have the atomic mass. This is the average number of protons and neutrons for all of the isotopes made by this atom. The atomic mass is similar to the mass number. Mass number is the number of protons and neutrons in the atom. This number is a whole number. To get the mass number, you just have to round the atomic mass to a whole number. So for carbon, we can round it up to 12, and 12 is our mass number. So that's how the element is shown on the periodic table. But more than likely, on an exam, you will be asked to write or show the elemental symbol. This is how we do that. Using carbon again as an example. We write the elemental symbol first. On the top left, we write the mass number. And on the bottom left, we write the atomic number. So you can see here, things are kind of flipped. And there you have it. This is the correct way to write out the element carbon. So what is a neutral atom? Or what makes an atom neutral? Neutral atoms are what you find on the periodic table. They have the same number of protons as they do electrons. And they have no charge. They are neutral. Let's take this carbon for example. What makes this carbon neutral? We know it has 6 protons because we can see it has an atomic number of 6. And because it is neutral, it has the same amount of electrons as it does protons. The positive and negative charges cancel each other out, and what's left is a neutral atom. Let's look at another example. On an exam, you will most likely see something worded kind of like this, where they ask you to find the number of protons, electrons, and neutrons in an atom with this given information. Here, the given information is the element calcium. We know it has 20 protons because it has an atomic number of 20. We know it has 20 electrons because it is a neutral atom. Same number as protons. And now to find the number of neutrons, we take the atomic mass and subtract the atomic number. Because the atomic mass is the number of protons and neutrons, and the atomic number is the number of protons. So we are left with the total number of neutrons, which happens to also be 20 in this case. Let's do another example using aluminum as our given information. Given the atomic number, we know aluminum has 13 protons and 13 electrons because it's neutral. Now round the mass up to 27 and subtract 13, we are left with 14 neutrons. By the way, are you able to find the atomic mass and the mass number? Remember, the mass number is a whole number and is the number of protons and neutrons. While atomic mass is a bit more complicated. It's a decimal number and it's the average of the protons and neutrons in the isotopes. So the atomic mass is 26.982 and that is given on the periodic table. And the mass number is just rounded up to 27. So we've gone over neutral atoms. Now let's go over ions. What is an ion? An ion is an atom with a charge. An atom gets a charge when it gains or loses electrons. An ion either has more protons than it does electrons, in which case it's called a cation with a positive charge, or it has more electrons than protons, in which case it's called an anion with a negative charge. The golden rule that you must never forget about ions is ions will always have the same number of protons as the atomic number. In other words, the number of protons never changes. You can only change the number of electrons because remember in the definition I mentioned, an atom becomes an ion by either gaining or losing electrons. So we're only manipulating the electrons, not the protons. So let's say we have an atom here, and the plus sign represents protons because they have positive charges, and the negative represents electrons. So this atom here has 6 protons and 4 electrons. These pairs cross each other out, and we are left with 2 extra protons. That makes this atom a cation with a +2 charge. Next, we have an atom here with 4 protons and 7 electrons. These pairs cross each other out, and we're left with 3 extra electrons. That makes this atom an anion with a -3 charge. This next example is how you will most likely see it on an exam. They give you information on the number of protons, electrons, and neutrons, or just protons and electrons because neutrons isn't too relevant here. And then you have to find the charge of the ion. So given the following information, write the charge for the following ion. So here we have 12 protons, 9 electrons, and again, the number of neutrons has no relevance to this question, so you could just forget about it. The pairs cross each other out, and we're left with 3 extra protons. That makes this a cation with a +3 charge. Next, we are given the following. Write the charge for the following ion. We have 9 protons, 10 electrons. Already we can say that this will be an anion because it has more electrons than it does protons. We are left with an anion with a -1 charge, or you can just put negative. The 1 is always implied, so you don't necessarily have to have the 1 there. So lastly, I just want to leave you with the trends of ions on the periodic table. So quickly, the group 1A, where you see the 1 plus or the 1 positive above, all of these elements will form a 1+ charge. So that includes hydrogen, lithium, sodium, potassium, and everything else on that row. Group 2A will form cations with a 2+ charge, and that includes everything on that row. And then transitional metals, it varies. More than likely, this is upper division chemistry, so don't worry about that. And then so on. So it's very important that you know that this is a general guideline to what what elements form these ions. So there are some exceptions to this rule, but this is a good start to remember the ion numbers on the top of the periodic table, because this can seriously save your life on an exam, remembering these numbers at the top, and of course, their negative or positive charges. Alrighty guys, so that's it for this video. Thank you for sticking around. I hope you learned something new, and until next time.